Okay, so last segment we talked about basically frequency, amplitude, intensities, frequency weighting, frequency bands, octaves, 1/3 octave, all such things, loudness, perception, all those things. Now we will get back to our system where we had a semi-infinite tube on which we were oscillating a piston and harmonically. Now you should be able to think what will happen if I oscillate that piston with some random shape. Say suppose this is the tube and you have the piston. Earlier you were oscillating it like sinusoid, but now I am telling you that suppose you oscillate that like this. So now your xi, some function of time, some random function of time. Can you now think of what to do if I ask you that find out the intensity and yeah, to start with, why don't you imagine that this shape is repeating after this shape whatever I have drawn is repeating. Okay, now how do you think, what's your thought process that now you are supposed to find out what is the energy content of, that means you want to draw that with frequency the octave bands, like that, this histogram I was talking about. So what will you do? What is the thought process? See, the thing is, this one because I said that it's a means repeating one, so obviously it has got a Fourier series representation, right? Now if it is having a Fourier series representation, what does it tell you? If you take the Fourier series expansion of this, the amplitudes will be there. Now that amplitude represents what? Of individual sinusoids amplitude, right? So that means you are oscillating this piston with different amplitudes at different frequencies. So those amplitudes square again, so they are say xi plus at say 10 hertz, then xi plus at say 20 hertz, so like that. If you suppose this is corresponding to 10 hertz frequency, so 10 hertz, 20 hertz, 30 hertz, you will get it. So there are many such xi's at different integral multiple of 10 hertz, and then at every such frequency you can calculate the pressure now, right? Because you have learned how to calculate for a given sinusoid when xi plus was say a plus e raised to say minus I omega t minus kx. For this you knew how to calculate the pressure intensity and all those sound pressure levels. Up to that point you know. Now this is just one step away ahead of that, saying that it is just having multiple of such things, nothing more than that. So if you do a Fourier series, you will get the different oscillations, add them up, and each individual's power level will be proportional to the square of that Fourier series coefficient of that particular frequency. So that is the meaning of the whole thing. And then if it becomes a completely non-repetitive one, you have to do a Fourier transform, and then you know now the Fourier transforms function is just like amplitude per omega. It is not exactly the amplitude per omega. So thus that has to be multiplied with omega to get in omega bands So you have to take short bands and then you have to do all calculations. Okay. So, but in principle now you understand what is the meaning of doing that. But then our next step should be, as we did in the string case, obviously to stop it here by putting something, right? Because this was a semi-infinite tube, but end conditions are important. So we should see what happens if we put some boundaries there. But that's a little bit more involved. So what we will do, we will go to a slightly simpler derivations, and then we will get back to this point again. Then okay, you will see the impedances and all, it's a bit involved, but we will get back to this, and I will remind you that yes, we have again come back to this point after around 2 hours of discussion on something else, and that something else is a simpler version of this. Okay. Now, but before going into that, I just want to summarize a little bit formulas, so that you will not get confused with forward, because we will be using them now quite frequently. So suppose I am talking about, and then there are some conventions of that minus I omega t and plus I omega t, and you will see a change in that which we will use. So that's why I am just writing. So positive going with e raised to minus I omega t convention. Okay. So if you are doing that, then your xi plus will be represented like what? So a plus, suppose e raised to minus I omega t minus kx. So that is one form, and then why I am putting them all together is that in books also, in the same book you will see multiple variations of the same formula. So you should not get confused, and you should know that okay, what exactly does it mean. Okay, so this you will see somewhere the same thing you will see as say minus, not minus, you will see as say I kx minus omega t. Then you will also see as e raised to I k x minus ct. So like that. So all these things are exactly the same. Okay. Now while I am writing the other versions, either you can follow me, or you can, if you are quite comfortable with these things, what you can do is you write the expressions for condensation delta, pressure, that means plus, then velocity plus. Okay. So I'll write now, so you try to write these expressions. And in the meantime, I'm writing say a negative, I'll write these things also. Negative going with the same e raised to minus I omega t convention. Okay. So you will write xi minus, okay, and this will be a minus e raised to minus I omega t plus kx, right? Then here this version is hardly it matters, it doesn't matter the switching of that. Only thing which matters is a minus e raised to minus I k, you take out, and ct plus, sorry, x, okay, or x plus ct, doesn't matter because it's just a plus, so hardly it matters. So this is for negative going with this. But then if I have to follow the other convention, that e raised to j omega t, because your book follows everything from now onwards what we will discuss, the book follows a convention of not this but of e raised to j omega t. So you can think that j is minus I and just replace minus I with j in all the expression you will get for that convention. Okay, so I'll just write for these two. So with this convention, positive going, okay, is z plus is a plus e raised to j omega t minus kx is equal to a plus e raised to minus j kx minus omega t is equal to a plus e raised to minus j k x minus ct. And for negative going with this convention, so I'll say negative going is psi minus will be a minus e raised to j omega t plus kx is equal to a minus e raised to j kx plus omega t, doesn't matter because it's plus, a minus e raised to j k x plus ct. So these are the full set of, in whatever way it can be written. Okay, but then thing is, when you calculate them, so I'll just write the see, this is nothing but this looks like a plus 4, this looks like a 4, it's actually plus. Thing is, you have to calculate all plus values and also minus values, and there you will see differences. I'll just see, so these from where you can write, this is nothing but minus of d xi over dx, right? And similarly this is nothing but rho naught c square d xi over dx, and this is nothing but d xi over dt. Fine. So because I have written xi for all the cases, so now you can find them out for both for plus wave and minus wave, all these values, because they are functions of xi only. Fine. Now if you do that, what you will observe is now I am writing, so please do that on your own. I'll just write now the answer which you will get. So now if I write say P, which is say P plus plus P minus. Suppose there is a point where both forward moving and backward waves are present, then they will be, in terms of the xi's, they will come out to be say j rho naught k c square xi plus minus xi minus. Okay. And similarly you will get delta as delta plus plus delta minus, you will get as j k times xi plus minus xi minus, and u is u plus u minus will be j omega xi plus xi minus. So, and all these things with the convention of e raised to j omega t. So, I am using j now. Okay, whenever I am using j, you should take or understand that I am writing in the e raised to j omega t convention. Whenever I am using I, it is e raised to minus I omega t convention. Okay. Now, you have to, why I am emphasizing on this is, in the books or literature, everyone will use their own convention, one of them, and based on that the lead and lag terms will be used. So, this is lagging that, that will leading this. So, you have to understand those concepts by properly interpreting these things. So, that is why I am saying this. How you should look at these equations are like pictorially you should visualize them. So, think always in terms of say xi. Okay. So, now this curve I am drawing for the positive moving wave. Okay. In this convention, e raised to j omega t convention I am trying to draw. Now, suppose xi is in this direction. So, I will write say plus also, because positive, for positive we are drawing. Then this equation tells you that the condensation delta is just j times xi plus. I mean k is just a number. So, this gives a phase of leading 90 degree. So, your condensation will be, in say this direction. I am writing delta now. Yeah, delta is 90 degree leading, because in this j omega t convention that phi equal to omega t moves like this, but in, so this in this convention, and in e raised to minus I omega t convention, from here you move like this, phi is equal to omega t, you move like that. So, these are the directions of movement which will be used to tell or use the word lag and leading. Okay, let us see first about this. So, this you will say that now, because the condensation delta is this direction, so delta is leading the displacement by 90 degree. Similarly, u also is leading the displacement by 90 degree. So, suppose now I draw u also is leading the displacement by 90 degree. P also, okay, that means P also leading. So, now it tells you that in forward moving progressive wave, okay, this picture I am telling in English now. In a forward moving progressive wave, this plus tells me that condensation, particle velocity and pressure all are in phase, and they are leading the displacement by 90 degree. Okay, this picture tells you that. And the d xi over dx is exactly in the opposite direction. So, this is lagging by 90 degree. Okay. Then what? Now, that was for forward moving wave. What if we try to draw the same thing for backward moving wave? For backward moving wave, let us say we have drawn say xi minus, okay. Now with respect to that, let's first think about say condensation delta. This is in the opposite direction, right? So that means condensation is in this direction. This is delta. Then pressure is also, let's say U. U is positive. So U I have drawn there with this. So U is this. And what about P? P is negative. P is this. So in a negative moving way, so this picture in English tells you that in negative moving progressive waves, condensation and pressure are lagging the displacement by 90 degree and the velocity is leading the displacement by 90 degree. Okay. Now because so this one is like lead, you know, and this is lag. If you write all these equations in the e raised to minus I omega t, you will get slightly, because again here everywhere wherever you see j, you can replace with minus I, you will get the expressions. And but then if you don't take into account this concept of in which direction I should call lead and lag, you will miss those words when they use. Okay. Because if you try to draw for the pressure in this case with the other convention, the pressure and all these three things will be in this direction. But you will have to tell that they are leading the displacement because the leading direction is in this, in the minus I omega t convention. Okay. So that if you keep in mind, there will be no confusion in reading different literature with different conventions. And now onwards we will be using this convention because the book uses this. Okay. But you know that it means nothing, just a convention. Okay. So we'll stop here for this segment and we will continue now with this. What I mean by you will use this to do what? Okay. We'll continue there.